Hey, welcome back, memers. We are going to do our very last lesson for factoring today. We're going to talk about mixed factoring. And you're going to say, mixed factoring? That sounds stupid hard. And it's actually not stupid hard. It's actually just a fancy way to say review, but with all of the different types of factoring mixed together. So what we're going to be worried about today specifically is figuring out how do I do each type of factoring? How do I figure out what type of factoring I should be doing to even start the problem? You know what I mean? So we're going to look at mixed factoring. Okay, so we're going to see a little bit of simple factoring, a little bit of complex factoring, some GCFs thrown in there, some grouping thrown in there, some sum and difference of cubes thrown in there. So there's quite a few examples today. I'm going to try and just blow through them, do them full speed because they're all review. We're going to focus on trying to identify what type of factoring to be doing and then do the factoring. All right. So before we start looking at the examples, let's talk about what are the 7 types of factoring and how can I see that I should be doing that type of factoring. So let's start with the most elusive, maybe most common, but most difficult to pin down type of factoring. And that's GCF factoring. GCF factoring could be almost literally anything. You have to look at the problem and see if they have any variables in common. So XX in every single term, or if the numbers have a common factor. In this case, it's 5, because 5 goes into 5 and 20. So you want to look at that first for every single problem. Even if you're doing one of these other types of factoring, you could have to do GCF factoring first because there can be a GCF in anything. So GCF factoring is the hardest to tell because you have to just know your times tables or have like an inkling or think, I should check, right? You have to remember to check is the thing. So that one can be a little tricky, but we'll just make a habit of checking. All right. Simple ABC, or just simple factoring, is the easiest to tell because there are going to be 1, 2, 3 terms, and then the number in front of the x squared will be a 1. Most of the time, that 1 will be invisible, but anytime you have 3 terms, and the first term is just x squared, it's got to be simple factoring. Easy as that. Grouping is the next most obvious. Grouping is the only one with 1, 2, 3, 4 terms. If you see a 4-term problem, it's guaranteed to be grouping. So you're going to look at the first 2, look at the second 2, and pull out some GCFs. Complex factoring, maybe a little harder to tell because you're like, oh wait, is it a GCF problem? Is it simple factoring in disguise? But the giveaway is there are going to be 1, 2, 3 terms, and even after you pull out a GCF, there's going to be a number in front of the x squared. You might have a GCF that you can pull out, but if you still have a number in front of the x squared, you're going to be doing complex. Difference of squares is a little easier to tell because you're going to have 2 terms and you're going to have this thing just dripping in perfect squares. You're going to have like 9. You're going to have a squared. You're going to have a 4. You're going to have 16s, 47s, 225s. You're going to have perfect squares all over the place. That's kind of the giveaway that it's difference of squares. Keep in mind, this has to be a minus. That's what the difference part is. Difference in math means subtraction. Okay. This one is only really easy to confuse with difference of cubes, which has some overlap, right? 64 is a perfect cube and a perfect square, so it could be a little deceptive. So sum and difference of cubes are almost the same thing. You're going to have 2 terms, except instead of squares everywhere, you're going to have perfect cubes. So you're going to have 1, 8, 27, 64. I don't remember the rest of them. There's a bunch of them, but you got to be on the lookout. All right. So that's what we're looking for. Most of the time you can tell by counting 3 terms, 4 terms, 2, 2, 2, 3. That'll help you narrow it down. And then you got to do some more fine-tooth examining. So let's go practice. All right. So I look at this first one. 1, 2, 3 terms. So it's either simple or complex. And there's nothing I can take out because this is a 1. So this is going to be simple factoring right away. So let's go ahead and do our simple factoring. I don't know that I've seen an example with a 4th power in one of our videos before. So we'll work through that as well. But simple factoring, we're going to start by looking at the last number, the term without any x's, and look at its factors. 2's only factors are 1 times 2. And to get a 3 by adding or subtracting in the middle, we're going to do 1 plus 2. So this is going to factor to something plus 1 and something plus 2. Now we have to ask ourselves, how can I get an x to the 4th? So x to the 4th, we want to multiply something to itself to get x to the 4th. What that thing is x squared, not plus, times. So x squared times x squared is x to the 4th. When you're multiplying, you're just adding exponents. So we're going to have x squared plus 1 and x squared plus 2. And that's factored. All right, let's look at this one. Another simple factoring, and we can tell because there are 1, 2, 3 terms, and the number in front of the first one is a 1 because it's invisible. So we're going to start by looking at our C term and factor that. So the factors of 42 are 1 times 42, 2 times 21, 3 times, is it 14? Not close yet. We need them to be 1 apart. So how about 6 times 7? That'll work. So we're going to use 7 minus 6 because we want to get a positive 1. So this is going to be plus 7, something minus 6, because those are the two numbers we're using. And then the two things that are going to multiply to give us x to the 6th, it's actually that thing right there, x cubed. You can always look in the middle. That'll tell you what goes in the front. So these are going to be x cubes. All right, there we go. There's our answer. Okay. These ones, oh no, we've got numbers in front. We've got numbers in front. So these ones either are GCF or, because they're 1, 2, 3 terms, they're complex factoring. So I need to see, can I take a 2 out of everything? No, 2 doesn't go into 9 or 5. So this is complex factoring. So we're going to go ahead and multiply our front number to the back. X to the 4th minus 9x squared minus 10. Now we're going to simple factor this. So the factors of 10 are 1 times 10 and 2 times 5. To make a negative 9, we're going to use negative 10 and positive 1. So this is going to be, what's in the middle? X squared minus 10 and x squared plus 1. Now we need to remember to divide by the original a term. So divide by 2, divide by 2. 2 goes into negative 10, negative 5 times. 2 doesn't go into 1, so we move it in front of the x squared. So we have 2x squared plus 1, and then this is our factored answer. Let's do another one just so we don't forget how to do complex. Check for your GCF. 3 does not go into 10 or 8. So multiply the leading coefficient to the last one. X to the 4th plus 10x squared minus 24. Factor 24 so we can make a 10. So we have 24 is 1 times 24, 2 times 12, whoops, not times 10, times 12. And then we could keep going, but this is what we want right there. That's the money. So we're going to do 12 minus 2 to get positive 10. And 12 times negative 2 is going to give us the negative 24. Check the middle to figure out what goes in the front of the binomial. So it's going to be x squared plus 12, x squared minus 2. Remember to divide by the original a. 3 goes into 12. 4 times. 3 doesn't go into 2, and we can't reduce, so we move it in front. 3x squared minus 2. There we go. All right. Now we look at these, and we say, oh, all right, 2 terms. These are either GCF, squares, or cubes. So we're going to start by looking for a GCF. They definitely share something. We have x's here and here, and 6 goes into 6 and 36. So we're going to go ahead and take out our GCF of 6 and some x's. We can take out 3 because that's the smallest exponent. Whoops, I erased everything. 6x cubed, 6x cubed. Remember when we're doing GCF, we put the GCF in the front, then we divide. 6 goes into 6 1 time. We had 6 x's. We took 3 of them out, so there's going to be 3 left. 6 goes into 36 6 times. We had 3 x's. We took 3 out, so there are no x's left. And then this is our answer. We should check this, though, just to make sure we can't factor some more. We can't in this problem, but it's a good habit to check if you're doing GCF factoring, just because a lot of times they make it multi-step, and you have to do GCF, then something else. All right. This one, there's a GCF, because we know 4 goes into 4 and 8. There's also shared x's. So we're going to take some 4's out, and then we're going to take some x's out. Because 5 is our smallest exponent, we're going to take 5 of them. So put your GCF in front. 4x to the 5th. 4 goes into 8 2 times. We had 6 x's. We took 5 out, so there should be 1 left. Minus 4 goes into 4 1 time. And then we had 5 x's. We took them all out, so there's no more x's. Can we factor this? No. So this is the answer. There we go. GCF examples. All right, let's go ahead and look at these. I think we only have a few left after this. So these ones look a little bit scary just because look how much stuff there is. Oh my goodness, Mr. Barton, you're killing me, dog. Oh well, it's good to be killed every once in a while. So we'll start with the easy one, then we'll look at the hard one. These are both dead giveaways on what type of factoring they are because there are 1, 2, 3, 4 terms. 4 terms always means grouping. So we're going to group the heck out of these. So let's look at the first 2 terms. What do these have in common? Well, there's no numbers in common, but they both have x's. So we can take x to the 2nd power out. So we're going to have x squared in front, divide. We had 3 x's, we took 2 out, so there's an x left. We didn't do anything with the 8, so bring down your plus 8. There were 2 x's, we took 2 out, no more x's. Close the parenthesis. All right, what do these have in common? Well, they don't both have x's, so it's got to be a number. I'm willing to bet it's 6. So let's try and take a 6 out. So we're going to put our GCF out in front. 6 goes into 6 1 time. Bring down your x. 6 goes into 48 8 times. Now we check. Do our parentheses match? Yes, sir. So now we're going to factor out the GCF. So we're taking out our GCF, which is this matching set of parentheses. So we're going to put that in front. X plus 8. Then, once these come out, we write the remaining stuff in their own set of parentheses. X squared plus 6. All right. Let's repeat the same thing for this slightly harder problem. And it's not really harder, it's just more, right? So what we're going to do is we're going to look for the 4 terms first. Just make sure we remember it's grouping. Then we're going to take out a GCF. So what goes into 27 and 18? I know 9 goes into 18. Is 27 multiple of 9? Yeah, it is, for sure. So we're going to take out a 9. And then do they have any variables in common? Well, this one's got some x's. This one's got some x's. So we'll take some x's out. And we can take 2 because that's the smallest exponent. So we're going to take out 9x squared. So we write that in front. 9 goes into 27 3 times. We had 3 x's. We're taking 2 out, so there's 1 left. 9 goes into 18 dose times. There were 2 x's. We took them out, so they're gone, but we still have this y left over. So put the y down. All right, we're done with the first 2 terms. Look at the second 2. What do these have in common? Well, 6, I believe. 6 goes into 12 and 18. And then what do they have in common? Variables. Well, it's got some y's, got some y's. So let's take out some y's, and the smallest exponent's a 2. So we'll take 2 out. So put down our GCF. Parentheses. 6 goes into 18 3 times. We had 2 y's, but we're taking them both out, so we just have the x left. 6 goes into 12 dose times. We had 3 y's. We took 2 out, so there's 1 left. Make sure your parentheses match right now. 3x plus 2y, 3x plus 2y. All right, they match. So let's go ahead and factor out that GCF of 3x plus 2y. So put that in front. 3x plus 2y. Those go away. We put the remainders in their own parentheses. 9x squared plus 6y squared. Make sure we can't factor. Oh, wait. Hold up. What goes into 9 and 6? 3. So we've got to take out a GCF of 3 from this thing. So take out 3. We're going to put that GCF all the way in front. Bring down this mess because we're not messing with it. 3 goes into 9 3 times. Bring down your x squared. 3 goes into 6 2 times. That's not a 2. Bring down your y squared. Now we are factored. And that's our answer. All right, cool. So what if there's a GCF? I hope you didn't hear that. That's embarrassing. Sorry, I've been working so hard. It's getting real late, you guys. It's almost midnight 30. That's a joke. It's not that late. That's way past my bedtime. But I do need a little sip of water. So what if there's a GCF? They're basically saying, hey, dummy, there's a GCF. Take it out. So let's take the GCF out of this thing. Let me see. Can I move this? Nah, someone locked it down. All right, let's put that in the middle so I got room to work. All right, what goes into 12, 26, and 12? It's not 6. 6 does not go into 26. I heard you think 6. It's not 6. What goes into this, though? Just 2? I think it's just 2, right? So let's take out a 2 from everything. Divide by 2, divide by 2, divide by 2. And then what else do they have in common? The x. So we're going to take out x's everywhere. The smallest exponent's a 2, so we're going to do x squared. All right. Put the GCF out in front. 2x squared. 2 goes into 12 6 times. We had 4 x's. We canceled 2 of them. We got 2 left. Plus 2 goes into 26 13 times. We had 3 x's. We took 2 out, so we're going to have 1 left. 2 still goes into 12 6 times, and we took both of these x's out. All right. Now, we're looking at this thing. We want to try and factor this. They gave us the hint that there's a GCF, but we should still try and factor this. There are 1, 2, 3 terms, and there's a number in front. So that's complex factoring. So we're going to multiply the first number to the last number. What a terrible arrow. Bring down the GCF. It's like your little brother. You can't lose it. So we've got x squared plus 13x plus 36. We're trying to factor this. So we're going to look at our factors of 36. There's 1 times 36. There's 2 times 18. There's 3 times 12. There's 4 times 9. Ooh, that's the money shot right there. That's how we get a 13. So again, bring down your GCF. It's your little brother. Don't lose it. This factors to x plus 4 and x plus 9. All right. Don't forget, we've got to divide by that number that we multiplied to the back. So we've got to divide by 6. All right. 6 does not go into 4, but we can reduce this. Bring down your GCF because it's your little brother. You can't lose it. 2 goes into 4 and 6. So we're going to reduce that to 2 over 3. 3 goes into 6 and 9. So we're going to reduce this to x plus 3 over 2. And then because these are still fractions, we move the denominator in front of the x's. Bring down your GCF. It's your little brother. You can't lose it. 3x plus 2 times 2x plus 3. We did it. That's factored. All right. Anything else? A couple. Don't worry. We're almost there. Now we've got to talk about sum and difference of cubes. And the giveaway is that big old cube right there. It's 2 terms and there's a cube in it. It's probably sum or difference of cubes. So we've got to remember our SOAP formula. A cubed plus or minus b cubed equals a plus or minus b, depending on what this is over here, times a squared minus or plus ab, always plus b squared. This thing is called the SOAP formula because this sign should be the same as what's over there. This sign should be the opposite. That's why they're flipped. And then this sign is just always a plus sign. So we're going to use this to factor these. So we've said, oh, I can see that this is sum of cubes because there's a cubed there. 27 is a number cubed, so is 64. So the first thing we're going to do is find a and b by taking a cube root of both of these terms. The cube root of 64 is 4, and then the cube root cancels the cubed, so it's x. The cube root of 27 is 3. Now we fill out our SOAP formula. So this is going to be a plus, because it should match the problem, b, times a squared. So 4x times 4x. 4 times 4 is 16. X times x is x squared. Opposite sign from what's in the problem, that's a plus, so we're going to put a minus. A times b, so 4 times 3 is 12. Bring down our x. Always a plus sign. That one's just always plus. B squared. 3 times 3 is 9. And that's factored right there. All right, one more. This one's a difference of cubes because we have a minus sign. Same process though. We need to start by finding a and by finding b. So we're going to take some more cube roots. The cube root of 8 is 2. The cube root cancels the cubed and we get x. The cube root of 125 is 5. Now we're going to fill in the SOAP formula. A, same sign as what's in the problem, so minus b, times a squared. 2x times 2x, 2 times 2 is 4, x times x is x squared. Opposite sign, so plus. A times b, 2x times 5 is 10x, always plus b squared is 25. That's factored. All right, I bet we got more. No, no more? No more? I think we skipped a difference of squares. So let's look at that. What's your favorite squared number? Let's think about it. How about 49? All right, let's make this one spicy just in case. X to the 4th. All right, minus, what's our other favorite squared number? 169. All right, this is a difference of squares because we know for sure 49 is a perfect square, so is 169. So just like over here for difference and sum of cubes, we took a cube root. We're going to take a square root for the squares. So we need to find a and b still. The square root of 49 is 7, of course. The square root of x to the 4th. We're asking what times itself gives us x to the 4th. That's x squared, of course. X squared times x squared is x to the 4th. So the square root of x to the 4th is x squared. So we're going to have 7x squared. The square root of 169 is 13. The formula for difference of squares is a plus b times a minus b. So we're just going to fill this in. We're going to have 7x squared plus 13, and then 7x squared minus 13. And that's the difference of squares. All right, ladies and gentlemen, another riveting video. I bet you were thinking to yourself, I hope this video goes on forever. I just love the sound of Mr. Barton's melodic voice. I love listening to him explain math to me. I love seeing such wonderful examples and knowing someone cares so much about my education. So, until next time, make sure you tell your mom that you love and appreciate her and everything she does for you, and make sure you like and subscribe. I'll see you guys next time.